In this video, you will learn how users benefit from easy and fast measuring with templates within Omicron's transformer diagnostic system using the CPC100 and the CP-TD1. Let's open a test template with the CPC editor. Now we prepare power factor or dissipation factor measurements for the bushings on phases A, B, and C and the neutral conductor. We set up the voltage-dependent measurements for phase A at power system frequency. The frequency-dependent measurements for phase A have already been prepared in the range from 17 to 400 Hz. In a similar manner, we set up the measurements for the other three bushings and save the test template. Now we open the test template in the CPC. The template contains the transformer data followed by the data for the A phase bushing. The first card includes the relevant information about the transformer type and its manufacturer. The second test card for the bushing of phase A contains the data for the voltage-dependent measurement, in which the dissipation factor or the power factor shall be measured at 2, 4, 6, 8, 10, and 12 kV at power system frequency. The third card includes the previously prepared frequency-dependent measurement. The measurement shall be performed at 17, 30, 80, 130, 230, 330, and 400 Hz. Here we can see the data for the B phase bushing, again including the technical data and the prepared voltage-dependent and frequency-dependent measurement for the power factor or the dissipation factor. The template also contains data and measurements for the C phase bushing and the bushings at the neutral. To measure the four bushings of our transformer, we start with bushings A and B and connect the test leads accordingly. In the first test card, UST-A is set. This setting allows measuring bushing A. Without rewiring, we can continue with measuring bushing B, because the next test card now switches to UST-B mode. Now we must reconnect the test leads once to measure bushings N and C. With UST-B mode set in the test card, the test leads are now connected to bushing N. The next test card uses mode UST-A to connect to bushing C, again without the need for any rewiring. The results of both the voltage-dependent measurement of the dissipation factor or the power factor and the frequency-dependent measurement of the dissipation factor or power factor are given. This is then repeated for the bushings of phase B, phase C, and the neutral conductor. All measurement results and test object data is saved in XML format, which allows easy transfer to database applications and further processing of the data on a PC. The Omicron Excel file loader provides graphical representation of the data in Microsoft Excel. In the overview, we see the transformer data on the left, and beside it, the technical data of the bushings for the three phases and of the neutral conductor. Here we see the results for capacitance and power factor or dissipation factor at power system frequency, showing the relationship between the power factor or the dissipation factor and the capacitance of the high voltage bushing, plus the dependency between the power factor or the dissipation factor and the frequency.